Welcome to Meki Study Circle channel. In this video, we shall see how to do the computer drafting of the isometric projections of the combination of solids. Moving on to the problem statement, we have a cylinder of length 100 mm and diameter 30 mm, which is placed over a frustum of a pentagonal pyramid as shown in the top view of the orthographic projection. So by looking at the orthographic projection, we can make out that the frustum of the pentagonal pyramid is composed of two pentagonal faces, the base face which is having a side of 50 mm and the top face which is having a side of length 25 mm, and also the height of the frustum is 60 mm. Moving on to the parameters of the cylinder, the diameter is 30 mm and the length of the cylinder is 100 mm. And moving on to the placement, it is placed in such a way that the axis of the cylinder is perpendicular to the axis of that of the frustum of the pyramid. So now with this data, let us proceed towards the construction of the isometric projections of the combination of solids. So in order to begin with this, first we need to enclose the pentagons in a rectangle, which I've already done here. So from the orthographic projection data, let us try to enclose this pentagon in a rectangle. So we have got a rectangle with the longer edge measuring 80.9 and the shorter edge measuring 76.94. So now let us begin the isometric construction. So let us select the line option and start constructing the base line of any arbitrary length, and then let us construct the longer edge of 80.9 dimension and the angle is 30 degrees, followed by the shorter edge which is 76.94 and the angle is 150. Next, we have got the longer edge again 80.9. So remember that the opposite edges will be having the same dimensions. So minus 150 is the angle. So next it is 76.94 and the angle is minus 30, which is correct. So now we have to construct the base pentagon. So for that, let us start measuring the dimensions. So on the longer edge, so we can just have the measurements for an instant. So this is the longer edge and this is the shorter edge. So over the longer edge, I need to mark this apex. So for that, let me use the distance. So from this corner of the rectangle to this opposite corner, so this is measuring 40.5. So let me select the line option, and over the 80.9, let me draw a line of length 40.45 mm. So this is the point. So this point I've marked. So next, let me go towards the other opposite edge, that is the longer edge, and take these 2 points. So for that, let me select the distance between and measure the distance of this corner and this distance, which is equal to 15.45. Similarly, from this corner to this corner, the distance is 15.45. So remember, it is again on the longer edge. So this longer edge, I've got this point. On this longer edge, I'm going to measure these 2 points. So let me select the line option. So from this corner, let me measure 15.45. The angle is minus 30. So again from this corner, let me draw a line of length 15.45 mm and the angle is minus 150. So I've got 3 points now, 1, 2 and then this point 3. So this point, these two corner points are on the shorter edge, that is 76.94. So what I can do is I'll take the distance from this corner of the rectangle to this corner of the pentagon, so which is 29.39, and it is from the longer edge. So from here, I'm going to measure a line of length 29.39 at an angle of 150. So now if I draw a parallel line, I'll be getting the opposite point also. So the parallel line is obviously the longer edge, 80.9 mm, and the angle is minus 150. So now I've got all the 5 points, that is the corners of the pentagon. So let me draw the pentagon. Let me change the thickness of the line to 0.50 and let me start from these two corner points. So this is one of the edge, followed by this edge, and the remaining edges is drawn. So this completes the construction of the base pentagon of the frustum of the pentagonal pyramid in the isometric scale. So now let us move towards drawing the top face of the pentagonal pyramid. So for that I need the axis. So let me select a line of thickness 0.13 and draw the diagonals of this particular rectangle. So from the point of intersection, let me take a length of the height of the frustum, which is 60 mm. So just remember that it is all done in the true dimensions in the system. So in the isometric sheet, take ISO 60, which marks the height of the frustum of the pyramid as given in the problem statement. So now let us go towards constructing the pentagon of the top face. So now for that, let me enclose this pentagon in a rectangle. So let me select a different color now. Let me select the red color line of thickness 0.13 and start enclosing this pentagon within the rectangle. So let me just use the zoom option to construct the rectangle for the top face of the pentagon. So you can just see that all the five corners are touching the edges of the rectangle. So now let me take the distance option and measure the distance. So the longer edge is 40.45, while the other shorter edge will be equal to 38.47. So with this data, let me construct this. So just remember that this is the shorter edge of the previous pentagon, and then this is the longer edge of this pentagon. So we need to draw the longer edge and the shorter edge parallel to the corresponding edges that we have drawn earlier. So that is 40.45 will be drawn parallel to 80.9, and 38.47 will be drawn parallel to 76.94. So this is the axis. So let me just change this line to the center line or the axis line type. So this is the axis of the frustum of the pyramid. You can just see that it is measuring 60 mm. So now let me draw the top pentagon. So 76.94. So opposite to that, I should be having the edge of 38.47. So here I need to take 40.45 by 2 as the center distance, and the angle is minus 30. Similarly, it is 40.45 by 2, and the angle is 30. So now let me draw the shorter edge, that is 38.47, and the angle is 150. So next the longer edge 40.45 parallel to 80.9, and the angle is minus 150. Similarly, the shorter edge, again shorter edge of this bigger pentagon and the shorter edge of the smaller pentagon should match. So it is 38.47, and the angle is minus 30. So if I just join this, so it will be half of 40.45. So now this part is complete. So now I need to construct the pentagon here. So let me use the distance between again. So let me consider this smaller rectangle. So it is at 20.23. So let me draw it here. So if I take a line option, 20.23 is here. So approximately the midpoint of this. And similarly, the other 2 points on the longer edge. So this point and this point, it is 7.73. So it will be symmetric here also. Let me just check. So 1, to 7.73. So let me just draw the line of length 7.73 on the longer edge. 7.73, angle is 30. Similarly, 7.73 and the angle is minus 150. So next I need to mark the point here, the corners here. So for that, select the distance between this corner point and this corner of the pentagon, so which is equal to 14.69. So it is a parallel line. So from the longer edge, let me take a line of length 14.69 and the angle is 150. So now I need to draw a line of length that is the longer edge, that is 40.45, parallel, that is minus 150. So now I've got these corner points. So now let me complete the pentagon on the top face. So select a line of thickness 0.50. So let me just join the endpoints here. So it is 7.73. So now the pentagon will be correct. So 7.73. So now let me just connect the corresponding edges, the slant edges. So now let me just change the thickness of the uh, invisible lines to 0.13. So now we have completed the construction of the frustum of the Pentagon pyramid. So let me just delete the dimensions which was used for the construction purpose, because in the isometric drawings the dimensions are not supposed to be shown. So now the frustum of the pyramid is over. So now from this axis line I need to draw the axis of the cylinder. So the axis of the cylinder is having a height of the total diameter of the cylinder, so that is equal to 30 mm. So let me take up the axis line of thickness 0.30, sorry, 0.13, and draw the axis line. So from this, let me draw a line of length 30 mm of the frustum of the pentagonal pyramid on the ISO sheet, or in the isometric scale, using the true dimensions. So we have not yet converted that, but however, the construction of the pentagonal pyramid frustum is complete. So you can just check that the frustum is having the height of 60 mm, and then over that I need to place a cylinder whose height is equal to 30 mm. So since this is the top view, you can just see that the height of the cylinder will be equal to the vertical diameter of that of the cylinder, which is equal to 30 mm. So I need to place the cylinder here. So now let us see how to place this cylinder. So for that, let us just construct the cylinder on a separate sheet or on a separate part, and then try to transfer that here. So for that, let me just construct this. So select the line option of thickness 0.13 mm. So let me just move on to a new sheet. So let me select the line option whose thickness is 0.13. So draw the square of side 30 mm, because it is having a diameter of 30. So the edge length is 30 followed by the angle, which is also 30. Next 30 mm and the angle is 90. So next it is 30 and minus 150, and complete the square of 30 cross 30 on the iso dimensions, that is in the vertical plane. I need to draw the circle. So next, let me consider drawing the ellipse by using the 4 center method. So from this corner, opposite edge is this. So I've joined the midpoint, and also the opposite edge is this, joining the midpoint. So from this corner, the opposite edges are this, and similarly this edge. So I've completed joining the opposite edges. I've got the 4 centers: center 1, center 2, center 3, and center 4. So now let me sweep the arc to complete the ellipse on the iso scale. So select an arc of radii 50 point thickness 0.50 mm. So this is the center one. So this is the arc. Next, center 2. This is the radii of the arc. Sweep the arc. Similarly, from the point of intersection, this is the radii. Sweep the arc. Similarly, this is the point of intersection. This is the radii of the arc. Sweep the arc. So now let us draw the axis of the cylinder from the center, that is this line. So the length of the cylinder is 100 mm and the angle is 150. Correct. So this uh, is the center point of the opposite square. So let me construct the square considering this point. So 15, the angle is minus 150. Similarly, this edge is 15, 15, and the angle is 30. 15, the angle is minus 90. Then draw a line of length 30 and the angle is 30 degrees and complete the square. So now let me use the 4 point center method to draw the circle. So this is the corner, the midpoint of the opposite edges. So this is one of the opposite edge. Similarly, the midpoint is here. So next from this corner, the midpoint is here for the opposite edge and the midpoint is here for the opposite edge. Now let me draw the diagonal. So let me go for the arc by center point. Select the thickness to be 0.50 and start sweeping the arc. So center 1, radii of the arc, sweep the arc. Similarly, center 2, radii of the arc, sweep the arc. So now center 1 and center 2 are utilized for drawing the arcs. So now let us concentrate towards the center 3 to sweep the arc. Similarly, this is the center 4, sweep the arc. So now the cylinder's two circles are over. So now let us draw the tangent. So let me just select the line option of thickness 0.50. So from this point, so this is how I'll draw the outer edges to show that this is a cylinder. So now let me just consider this arc and this piece of the arc and make it a thickness of 0.13 because it is not visible to the observer. So select this. So let me use the split option. Select the entire arc, split it at this point. Similarly, select this entire arc and split it at this point. So now let me select this piece and this piece of the arcs and make it a thickness of 0.13. So now the cylinder is complete. So let me just trim this line also. So this is the axis of the cylinder. So let me change the type to axis, that is the center line. And let me draw the midpoint From the midpoint, it is 15 minus 90. So this is the axis reference. So this is the one which has to fit on the axis of the frustum of the pyramid. So let me just change the type to the axis. So now this entire cylinder will be selected. Let me just move this. So now you can just see that the cylinder is ready, and I need to place the cylinder on the axis of the uh, frustum of the pyramid. So you can just see that it is placed like this. So exactly the center point. So this part of the frustum of the pyramid shall be made invisible now. So select the, let me just keep the midpoint off. Select the entire edge of the pentagon and split it at this point of intersection, and similarly this entire edge and split it at this point. So this part of the pyramid, this part and this part of the pyramid edges shall be made 0.13. So this is how the construction of the combination of the solids, that is a cylinder with its axis perpendicular to that of the axis of the pentagonal pyramid, is placed as seen from the top view of the orthographic projection. So with this we complete the construction. So now it is time for us to reduce this to the iso scale. So select the entire set and go for scale option. Change the scale to 0.816 and so with this, we complete the construction of the isometric combination of the solids, wherein a cylinder is placed in such a way that its axis is held perpendicular to the axis of the frustum of the pentagonal pyramid, as stated in the orthographic projection given in the problem statement. Thank you all for watching.